we know what a scalar quantity is. A scalar is something that has magnitude and no direction. For example, weight. Okay, weight of rice. Let's say it's a 5 kilogram of rice or 1 liter of milk. These are scalar quantities. So scalar quantities, or you just simply you can say scalar is just a number. Just a number. So the addition of two scalars, multiplication of two scalars is just numeric operations. Similarly, what is a vector? A vector is having both, not only the magnitude but also direction. Okay, attached to it, direction attached to it. For example, if this is a positive x-axis, okay, and there is an object on the x-axis, you apply a force of 20 Newton. So we always not only say the magnitude part of the force, which is 20 here, but we also say along with 20 that 20 Newton force in positive x-axis or in the right direction. If it is just one dimensional, then it is in the right direction or in the left direction. Okay, so we know, so this is the thing about a scalar and vector. The vector is a magnitude and direction both, and a scalar is just a number. And scalar addition or scalar multiplication, all of these things are just numerical operations that you know how to do. And when it comes to vector, there is two things that we will look into, which is vector addition, vector addition, and scalar multiple of a vector. A scalar multiple of a vector. And believe you me, everything else related to vectors, all of them, they are nothing but means any vector operation, they can be written in terms of vector multiplication with a scalar and vector addition. So let's look into the vector addition. How vectors are added? As we know that vectors, there is direction to it, to a vector. Okay, first of all, look into representation of vectors. How do we represent vectors? So let's suppose we are talking in terms of a 2D space. Okay, and this is the origin to it. And let's say there is a vector like this. Can we say that this is a vector? Yes, of course. Why? Because, okay, this is one of the representation of the vector. What is it? This is nothing but the length, means representation of a vector as an arrow. This is the length of this arrow represents the magnitude of the vector. Okay, and the pointing of the array represents the direction of the vector. So this vector, let's say this is 5. Okay, the length of it is 5 units. Okay, so if this is 5 units, what would be the, let's say this is 4 and this is 3, right? Means that means satisfying the Pythagoras theorem. So this is your vector. This is your vector. So the origin of it is the origin only, which is 0, 0 in this case, and it is going till what is the coordinate here? 3, 4. Okay. So how do you represent a vector? So vector can be represented based on different applications. Particularly in linear algebra, we will see a ordered a vector represented as an ordered list. Okay, but these are different ways of representing a vectors. One is this arrow, using an arrow. Using an arrow, the length of the arrow, which is here 5 units, represents the magnitude, and the pointing of the arrow represents the direction of the vector. Okay, and we know that vectors can be moved. You know, the parallel vectors of same magnitude why I am putting this vector always on the origin? This might be the question. Then vectors can be moved, you know this, right? Like this vector or this vectors are same. I mean, in physics this is what it is. I am not talking about linear algebra yet, so do not confuse. I'm just talking about vector in general. So and we have studied in physics that these two vectors, if this is also 5 units, then this is nothing but the same thing. So I'm just writing it on the the initial tip of the vector on the center, just so I can get the proper coordinates for it. And that's how you do it actually, to get the proper coordinates. Okay, we will look at the linear algebra part of the vectors just in a little while. Okay, let me tell it directly. In a linear algebra, what we do is, what a vector is simply a list, and this is an ordered list. Ordered list in the sense that in this case you have two axes. Let me denote those axes as x and y axis. Okay, so this is x axis and this is your y axis, and with relative to this axis only you are giving coordinate to a point. If this is a point, so relative to x and y axis only you are giving the coordinates to the point. So in the ordered list you have nothing but the ordered coordinates. Means first you write 3 and then you write 4. So this is how you can represent a vector using an ordered list. So you can represent a vector using arrow, you can represent a vector using an ordered list of coordinates, or simply as a point, because for a given coordinate there is going to be only one point, so this is one of the point. So there are 3 ways to represent one vector. So let me give you all those 3 in another page. Okay, so these are the 3 ways to represent a vector. This coordinate is 3 and this is 4. Okay, very good. Now, so far we have seen about what a scalar is, what a vector is, and the scalar addition, multiplication, you know that very well. It's just a number, so you know this. When it comes to vector, every vector operation can be written in terms of the vector addition and a scalar multiple of vector. So let's look into both of these things. Scalar multiple of a vector. Let's say if this is a vector, say. So what does it mean to say 2a vector? It means nothing but direction remains the same. Okay, if this scalar is positive, it means that the magnitude of the vector becomes double. Okay, and because this is a positive direction, because it is positive number, so direction remains the same. Direction remains the same. If we would have done -2 into a vector, then what it means? It means that the magnitude gets doubled. No doubt, magnitude gets doubled here also. But because of the negative sign in the scalar, or because it is a negative number, or because the multiplication of a vector is with a negative number, it means that direction has got completely reversed. So if the a vector is this, okay, then 2a vector would, okay, I will show you in the next page. So direction changes to in the opposite direction. Direction changes to the opposite direction. To the opposite direction. Okay. So for any general k a vector, so for any general, if I take any scalar k, then what does it mean? Then what is k into a vector? If you take any scalar k, then what is a into k into a vector will be? So it will be, if I represent, okay, let me take a new page. For any scalar k, then what would be the magnitude of k into a vector? It will be k into whatever the magnitude of a vector was. Okay, and what will be the direction of k into a vector? It will be equal to plus a vector if k is greater than 0, or minus a vector if k is less than 0. Okay. Okay. Now let me explain it. For a, means this is what happens. So if this is your, so let's say if this is your a vector, okay, then in the same direction, if k is greater than 0, let's say k is equal to 2, then in the same direction this whole vector is 2a vector. Okay, and what would be a minus 2a vector? Means when k is equal to, this is when k is equal to 2. What if k was equal to minus 2? What if k was equal to minus 2? Then the direction of the vector would be changed and magnitude would be doubled. Okay, just in the opposite direction, in the straight line itself, but in the opposite direction, it is nothing but this is what a minus 2a vector would be like. Okay, let's say this is your x-axis and this is y-axis. Okay, and the coordinate at x-axis is x1 and the coordinate of this point at y-axis is y1. Then how do you represent a vector? Then a vector is equal to x1 y1, right? I mean, you can represent it in as a column way, or previously I have represented it as a in a horizontal manner, but it is just an ordered list. Listen, vector is an ordered list of coordinates. The content will be the coordinates only, but if you choose to represent it like this, we will say that it as row vector, and if you represent it in this manner, we will say this is as column vector. Choice is yours. But what I'm asking is that because of this 2a operation, or because of this operation of multiplying 2 to the vector magnitude have increased to 2 into whatever the magnitude was. So if the magnitude was a, then it has increased to 2 into a. Okay, so what I'm asking is, what is the values of the coordinates now? What is the values of the coordinates now? You will find that the values of the coordinates will get doubled itself. Okay, you will find that if this was x1 and you had applied 2 into a vector, then this coordinate is nothing but the new x coordinate after 2 into a vector. The x coordinate is 2x1 and the y coordinate is 2y1. Okay, similarly here the x coordinate will be minus 2x1 and the y coordinate will be minus 2y1. Okay. So what happens in a scalar multiple of a vector is nothing but each coordinate gets multiplied by k. If you perform k into a vector, then each coordinate gets multiplied by k. K into a1, k into a2. Okay, we have only taken up to 2 axes, so let me do it that way only. So k into a vector, k into a1, k into a2. Okay. So this is what happens. This is all about the scalar multiple of a vector. Okay, now let's look at vector addition. Okay, what is a vector plus b vector? This is what you want to find out. What is a vector plus b vector? So the triangle, according to the triangle law of vector addition, how we will get a vector plus b vector? So this is your a vector. Okay, then you just put the tip or the initial tip of the b vector on the arrow of the a vector, and this is your b vector now. And this make a triangle. Okay, and this third side is what is a vector plus b vector. This is the triangle of vector addition. This is how you get a vector plus b vector. Okay, so this is triangle law of vector addition. There's another way you can find sum of two vectors, addition of two vectors, which is parallelogram law of vector addition. In parallelogram law, what you do? In parallelogram law of vector addition, this is your a vector, okay, and b vector. The initial tip of both coincides. Okay, and so this is your b vector. How can I make the initial tip of b vector coincides with the initial tip of a vector? This is what you get. Okay, now using these two, this a vector and b vector as two sides of the parallelogram, then this is the parallelogram that it will make. They will make together. Then the diagonal, this diagonal is what your a vector plus b vector is. Okay, now you can just think about this. Had you put 1 minute, now think about this. Had you put this b vector not here but this as b vector, then this a vector plus b vector is nothing but the third side of the triangle, right? So these are two methods of vector addition. Now my question is, okay, so this is a pictorial representation where you are representing vector with an array, and the length is representing the magnitude, the arrow sign is representing the straight direction in which this vector is about. But what happened to the coordinates? For example, let's suppose for a given reference axis, okay, for a given reference axis, it would be a representation of a vector as ordered list. Similarly, for a given axis system, okay, or given reference coordinate system, you can say there would be some ordered list representation of b vector also. I am representing it as a column vector. You can whatever it is, but this is a list of coordinates. Now during the addition of a vector and b vector, what happens means, what is the coordinate of the a vector plus b vector? What I mean to say, just a minute, look at this. Let's suppose this is your a vector, okay, and we are talking in terms of means x-axis and y-axis, means only two axis system. So let's suppose, or 2D space. Listen, I suppose 2D space, 3D space, something that you know, you have a little idea about. We will look into vector space later on, okay, but you can understand what I am saying right now. So a vector is equal to, let's say, a1 and a2. These are the initial coordinates of a vector, and b vector is equal to b1 and b2. These are the initial coordinates of b vector. Then what is the coordinate of a vector plus b vector? Okay, you will find out that this is nothing but you just have to add the corresponding coordinates. Okay, so this is nothing but a1 plus b1, and this is nothing but a2 plus b2. Okay, so I can very well say that this scalar multiple of a vector, or multiplication of a vector with a scalar, is what we are doing is every coordinate we are multiplying it with a scalar, and okay, so every coordinate gets multiplied by k, which is a scalar, right? And in case of vector-vector addition, what I can say is that the addition of vectors is nothing but adding the corresponding coordinates. Right? Now we have seen examples, means for explanation purpose we have seen this with only cases with where we have two axes, x-axis and y-axis, and we are naming these axes as x and y-axis, right? Means as a reference axis you can say, but in reality there can be a vector can have n coordinates. Okay, let's suppose if this is your vector a and b, you will say that this belongs to R2. If your vector is having 3 coordinates, then you will say this vector belongs to the R3 space. Similarly, you can have total, let's say taking n, you will say this is a vector in Rn space. Okay, we will look into the detailing of this vector space, all of these things in upcoming videos. Okay, so everything remains the same. In case of n dimensional, what does it mean to say k into a vector? It is nothing but k into a1, k into a2, k into a3, and so on k into an. Similarly, what will be, let's say if a vector is this, if this is your a vector and b vector is equal to b1, b2, and so on bn, then a vector plus b vector will be a1 plus b1, a2 plus b2, so on an plus bn. Means that the vector addition is simply the addition of corresponding coordinates, and a scalar multiple of a vector is simply multiplying each coordinate by the scalar. Okay, so let me give you a little intuition behind all these things. Okay, let's say this is your one vector, this is one vector which is a vector. Okay, and there is another vector which is let's say this is your another vector which is b vector, Now when you are adding this a vector to b vector, okay, then because we can very well add these two vectors using parallelogram, because the initial point of both of them are meeting at one place at the same point. So this diagonal of the whatever the parallelogram you can make. Okay, so this is the diagonal of that parallelogram. So this diagonal is your A vector plus B vector according to parallelogram law of vector addition. Okay, and what I am saying is that if the coordinates of this point is A1 B1, A1 A2 let's say, and coordinates of this is B1 B2, then coordinate of this will be A1 plus B1 and A2 plus B2. This is what I mean by vector addition. Okay, in machine learning what we do is basically we treat the data as a table, means that table as a matrix with each row as a vector. Okay, if you see every column name, okay, is like a feature. So for every column name is a feature, and every row contains the values for each columns or for each features. So so definitely we convert every number, everything, every feature. If that feature is not not a numerical, let's say if it's a text data, then we convert that feature first into a vector. And so these are the things that you will come to know, what to make and others. We will I'm not going to go into that right now. Okay, but why I started speaking about that, something came to my mind. So yes, so what we do is basically every row we treat it as vector, and the whole of the table we can then think of it as a matrix. So we actually use linear algebra a lot, and probability too in machine learning. Okay, so that's why I started with this vector and scalar concepts. Okay, let's just quickly look at the scalar multiple also. Let's say this is your one vector B vector, and so there's going to be some coordinates of it. Let's say it is a B1 B2, B1 dash B2 dash, and when you apply 2 into B vector, it means that this vector is stretched in the same direction and its magnitude has become twice. So the new coordinates that you get here is basically B1 2 into B1 dash and 2 into B2 dash. This is what I just wanted to show graphically. Thank you very much. We will see in the next video for this linear algebra series.